Cache memory. So, in this video we will understand what is cache memory in computers and laptops. What is cache? Cache memory is a small-sized type of volatile computer memory that provides high-speed data access to a processor and stores frequently used computer programs, applications, and data. Cache is a term which is common heard today. With exponential advancement in field of faster processors popping up every day, the usage of this terminology has increased rapidly. This has also been the most major parameter in faster processing. But what is cache actually? Is it processing unit or memory? Where is it? What is L1, L2 and L3 cache? What is the actual process of storage of data? To understand this, first we need to have insight about how CPU works or how it processes. So let us take a look. Characteristics of cache: location, capacity, organization, performance, access method, physical type. Location of cache: CPU, external, internal. Memory organization: CPU, central processing unit, is just like brain of a computer and performs the arithmetical logical operations of the system by carrying instructions on the code. The memory organization of a system is shown. At the core is CPU, and then our cache, then RAM and then storage device. What is the actual process of storage of data in memory? This memory is generally divided into different levels. In the following figure we see the process flow. But how these work? First comes the storage devices. When an application starts or data is to be read, written, or any operation is to be performed, then the data and commands associated with the specific operation are shifted from a slow-moving storage device to a faster device, RAM. Second comes the RAM. This faster device is RAM, random access memory. This RAM is type of DRAM, dynamic random access memory. RAM is placed here because it is a faster device, and whenever data commands instructions are needed by processor, they provide them at a faster rate than slow storage devices. They serve as a cache memory for the storage devices. Although they are much faster than slow storage device, but the processor processes at much a faster pace, and they are not able to provide the needed data instructions at that rate. So there is need of a device that is faster. Then comes the cache. Therefore the data required is transmitted to the next level of fast memory, which is known as cache memory. Cache is also a type of RAM, but it is static RAM, SRAM. SRAM are faster and costlier than DRAM. Moreover, they need not be refreshed periodically because of bistable latching circuitry, unlike DRAM, making it fast. Level 1 cache. So, in this level 1 cache, tiny amount of memory is integrated inside the CPU itself. and all the cores inside CPU have their individual level 1 cache. So, as this level 1 cache integrated inside the CPU, so they can operate at the same speed of the CPU. And that is the reason level 1 cache is fastest among all caches. Level 2 cache. It can be connected to both inside and outside CPU. But in terms of the speed, they are slower than the L1 cache. Level 3 cache. This level 3 cache is used to enhance the performance of this level 1 and level 2 cache. And it is outside the CPU. But it is slower than the L1 and L2 cache. So, now let's see the process flow. When CPU needs some data, first of all, it registers the data. Then, it will look inside the L1 cache. If it will not find inside the L1 cache, then it will look inside the L2 cache. And if data is not inside the L2 cache, then it will look into the L3 cache. So, if CPU finds the data inside the cache memory, then it is known as a cache hit. But if data is not available inside the cache, then it is known as a cache miss. After cache miss, the CPU will look inside the RAM and then in storage devices. Now, you may ask that, if this cache memory is so fast, then why the size of this cache memory is only in megabytes? So, the reason is that this cache memory is much costlier than the other memories. So, whenever you are buying some desktop or laptop for yourself, don't only look the RAM, but also look how much cache memory that CPU has, because this cache memory decides the overall performance of the processor. Thank you for watching my video. If you liked this video, please give a thumbs up. Share this video and subscribe because it's free. Thank you for watching my video. If you liked this video, please give a thumbs up. Share this